This is the part 3 video on force and motion. In this one, I'm going to be talking about Newton's third law, terminal velocity as well. In the first video, part 1 video, I was looking at frictional force, balanced forces and unbalanced forces. The second video, I was looking at Newton's second law, that is momentum and impulse. Now in this one, I'm going to be talking about Newton's third law. Please remember to subscribe to the Physics Tips for Cambridge Students YouTube channel, as well as to hit the notification bell so that you get alerted of future videos. Without much further ado, let's get started. Now, if you consider the example of elastic collision that I covered in part 2 video, which is this one here, right? So this exerts a force. Trolley A exerts a force on trolley B, which was stationary, and then trolley A would come to rest, while trolley B would then move off with twice the speed that trolley A had initially. Now A exerts a force on B and changes the momentum of B from 0 to something. The lost momentum of A equals the gain in momentum in B. So B exerts an equal but opposite force on A to change the momentum of A. So this then gives us a clear picture of Newton's third law, which is summarized as: to every action there is an equal but opposite reaction. Please note that this is not the way you should state Newton's third law of motion. It's just a summary of it. The actual law states that if object A exerts a force on object B, then object B would exert a force, an equal but opposite force, on object A. The law tells us that the forces occur in pairs, which are called action-reaction pairs. For example, a runner. The runner pushes back on the ground, that is the action. So the ground would then push back or forward on the runner, which is the reaction. Book on the table. The book pushes down on the table then pushes up on the book. A balloon. Air leaving a balloon pushes on the air outside the balloon. Then the air outside pushes on the balloon, right? So we have those hot air balloons. What makes them rise is because of action-reaction pair. Now I'm going to look at terminal velocity. So terminal velocity is the maximum velocity an object reaches when falling in air or in a liquid. This is when the opposing forces are equal and opposite to each other. So in this case, it's going to be the force of gravity, which is the weight, and air resistance, which will be acting in opposite direction. So when the two equal each other, then the object continues to move with a constant speed, which is called the terminal velocity. Now I'm going to look at the case of a parachutist, which is a skydiver falling from a plane. Right. So the plane takes off, and then when it is a certain altitude, then the skydiver would then get ready
when
to
a skydiver jumps out
fall
of a plane
from the
at
plane.
3,000 meters, her speed goes through some big changes.
So there we have the skydiver ready to fall from the plane.
The forces as you fall through the air?
Right, so initially the parachute is not open. The skydiver falls with an acceleration due to gravity, and then air resistance would tend to
Before the
increase
skydiver
fast to
jumps,
match the
the floor of the
weight.
plane provides a
So the
counterforce,
downward
which
force there
balances
is the
downward
weight,
force
which
of
is in
gravity,
green.
right up
Air
until the moment she
resistance
steps out.
is in red. So as you can see, as the skydiver falls, there is only the weight that is free fall.
Gravity immediately pulls her
Only
towards
the
the
weight
ground,
acting
and she
on
starts to
her.
accelerate downwards.
And then
But air resistance is
air
acting in the
resistance is
opposite
small,
direction.
but is gradually increasing
The faster she falls, the
until
greater
it
the air
matches the
resistance.
weight going down.
Eventually, the upward force
Now
of
when
the
this
air
happens, the
equals the
skydiver is
downward
now
force of
falling at a
gravity.
terminal velocity. This is called the first
When
terminal
forces are
velocity,
balanced, the speed
but this
remains
is
constant.
unsafe for landing.
That doesn't mean she stopped falling. It
So
means she
what does
stopped
the skydiver
accelerating.
then do? Then
She's still
opens
doing
the
a steady
parachute
55
so that
meters per
lowers
second,
this
and hitting
55
the
meters
ground
per
at this
second
speed isn't a good
velocity,
idea.
which is unsafe for landing. So then opens the parachute.
To slow
This
down,
then
the upward force
increases
needs to be greater
the
than
air
the downward
resistance.
force.
So momentarily, the
When
air
the
resistance will
parachutes
be
open,
greater than
air
the
resistance
weight.
suddenly becomes much greater than gravity. The forces are no longer balanced, and this changes her speed.
So
She
then
slows down.
the speed then drastically changes or goes down to now it's a 12,
Because she's
11,
slowing down,
10,
air resistance
9,
decreases
8,
until it balances
7,
gravity again,
6,
and
5.
she reaches a much
Now
slower
5
constant
is
speed.
safe for landing. So the skydiver now falls slowly at this new terminal
Approaching the
velocity, which
ground
is
at
5
5
meters per
second
second,
is a much better idea.
which enables him to hit the ground with a reasonable force.
As she hits the ground, there's a thumping
Right,
great
so
counterforce from the
touchdown,
earth,
there's going to be
which
thumping
decelerates
force
her
from the
very
ground,
quickly.
and this skydiver has to run and then decelerate. So that's what takes place during this. Right. So to summarize what we have just gone through there, the skydiver initially is accelerating downwards due to gravity. There's no other force acting. It's just gravity. And then as the speed increases, drag also increases, going up until drag equals the weight. So this will be the first terminal velocity, which we saw to be about 55 meters per second, which is unsafe for landing. Then the skydiver keeps falling, but then has to open the parachute so that there is a sudden deceleration when the parachute opens. So the speed of the skydiver then drastically reduces to about 5 meters per second, which is safe for landing. This is the second terminal velocity. Then when the skydiver hits the ground exerts a force to balance the gravity. Right. So looking at the graph, so initially we are saying that the skydiver falls. So as you can see, there's a straight line graph, velocity time graph, straight line, which means that the gradient is constant, the acceleration is constant, which is the acceleration due to gravity, 9.81 or 10 meters per second squared. And then at this point here, the speed is now decreasing. Sorry, the speed is increasing, but then it is the gradient is the one that is decreasing. So the acceleration is decreasing to 0, which is our first terminal velocity, which is about 55 meters per second. Then this is the point where the parachutist opens the parachute, and then the speed drastically changes within a very short space of time to reach about 5 meters per second, which is the new terminal velocity, which is safe for landing. I think I'm going to end the video here. Please make sure you comment on any part that you don't understand, and remember also to like, share, as well as to subscribe to the channel. Signing out.